One is up here as well.
Oh, thank you. Alrighty. All right. Hi, everyone. My name's Megan, and I'm going to be presenting work I've done with Bonnie Nazari and Dan Yarovsky about the role of production and feedback in language learning. So children aren't directly taught how to speak, but somehow they learn the patterns and rules of their native language. And developmental research has often focused on this question of how children make statistical inferences based on parent input in order to learn their language. However, parent utterances are not the only input children hear. From the time they start to babble, children hear their own utterances and interpret how others react to them. So my project attempts to understand how children's own utterances and the responses they hear to those utterances might shape their learning. For example, our language is filled with patterns about what sounds occur at certain parts of a word. So for example, in English, the NG sound at the end of king hardly ever appears at the start of a word. And while being asked to produce a novel language with rules like this, children learn these rules faster and more robustly than adults do. So as children are speaking, they might use their utterance as examples of the rules of language, and that might help them remember these rules, perhaps even better than only hearing their parent produce it. However, children's production is often filled with lots of mistakes, more so than the utterances they hear. So if children learn from their own utterances, how do the mistakes they make affect their language understanding? For example, in English, when a child makes an irregular plural error, such as overgeneralizing the add s to plural nouns, saying, "Look at our snowmans," how does that affect learning? Well, there are two theories about how production errors like these might affect children's learning, given that they pay attention to their own speech. Errorless learning theories, which suggest that preventing children from making errors in the first place is the best way to help them learn. Because when they make errors, they learn that error as the target of production. In this scenario, snowmans would be learned as the correct label here. However, other research suggests errors may be extra helpful for learning, because feedback to these errors helps children identify their mistake and learn the correct form instead of their error. By saying snowmans and getting feedback, they update their representations to reflect the correct form, snowmen. However, do children get sufficient feedback to learn the correct form? Well, grammatical errors, like irregular plurals, often get different responses than semantic errors. So when the child calls a horse a dog, a parent is likely to respond, "No, that's a horse," or try to clarify they've understood the child, tell them they were wrong, and provide the correct label. However, when a child makes a grammatical error, the parents are less likely to make any kind of explicit correction because the meaning behind what the child said was correct. So instead, in response to their child saying something like snowmans, they might respond, "Wow, what cool snowmen." And this type of feedback is called a reformulation, because the parent takes the child's error and fixes it in a new sentence. But since this feedback is not explicit, it may be unclear whether the parent is providing a correction, therefore making it hard for the child to learn the correct form when they make an error. So therefore, when making irregular plurals, children may still learn their error as the target of production. However, there is some evidence that children learn from these reformulations. So Chenard and Clark show that parents are more likely to reform errors than to repeat correct utterances, meaning that these might be an especially frequent and salient cue. In their analyses, children appear to acknowledge or even correct themselves after these reformulations. And in experimental design, children learn novel irregular verbs better when they heard reformulations compared to when an experimenter provided the word form first before they could attempt the label. However, there are some limitations to these studies that prevent us from concluding that children use error-based learning mechanisms to learn from their irregular plural mistakes. First, corpus analyses like these that show reformulations are frequent and informative are often based on small sample sizes, as this study only looks at 5 children. Additionally, the experimental studies, like those of Saxton, may not replicate the naturalistic environment in which these reformulations occur. In particular, these contexts focus heavily on word learning. Children know that they do not know these novel words and are repeatedly trying to learn from the experimenter. In more casual conversational contexts where caregivers are talking about familiar items like mice and geese, children may not pick up on these implicit corrections. So therefore, we want to conduct a series of studies to improve on these limitations. First, we'll conduct a larger corpus analysis to assess whether parent reformulations are a frequent and clear learning signal. And then we'll conduct a series of experimental studies. We assessed whether children learn better from either avoiding errors or by receiving feedback to their errors. And then we conducted a follow-up study to address some limitations in that first study, specifically to see whether the simplicity of the feedback improves clarity. So together, these studies will assess the effect of children's productions on learning and whether their own errors either reinforce the irregular forms through errorless learning mechanisms or provide an opportunity for learning through error-based mechanisms. So we sampled from the Childis English, North American, and UK database, and we looked for any time one of these 8 target words were spoken by the child. And these were chosen because the errors are common, irregular plurals children encounter, and will be the ones we use in our experimental study. We searched for any time the child produced the correct form and 2 common overregularization errors, such as mouses and mices. So this led to a sample of 2,394 utterances across 223 children. We then looked at the 2 utterances following the child's production to see whether parents either repeated the child's production or reformulated their production, to assess how frequently children receive corrections. And given prior research, we should expect that reformulations be really common given an error, and that children should acknowledge and correct their mistake. So this graph shows that given when a child either produces a correct or incorrect form, what kind of responses parents gave. And we found that parents repeat both correct and incorrect utterances, while parents only reformulate errors. And we did find a lower rate of reformulation than Chenard and Clark, about 27%, and they were not more common than replays. So if children learn through error-based mechanisms, reformulations are a clear signal, but they do appear less often than previously thought. And at least immediately after, children are not more likely to repeat the correct form than they are to say the error again. So could children employ error-based mechanisms to learn irregular plurals? Well, if children can pick up on the implicit corrections, it's a good signal, but they do appear less frequently than expected, maybe making it harder to interpret. And indeed, in this analysis, children don't always take them up immediately, which casts doubt on whether children can use this correction in everyday interaction. Therefore, we wanted to conduct an experiment to see whether children's production improves through error-based learning, or whether errors hinder learning. So this game was played over Zoom. We had 3 and 4-year-olds who were told they would help me fix my dream machine. We tested them on the 8 irregular plurals that we looked for in study 1. And first, children at pre-test were asked to greet pairs of pictures, saying hi geese or hi gooses. And then children proceeded to the training phase, where they were told to count the pictures in the correct dream, the dream that has the trail of bubbles. And they were divided evenly into one of 2 conditions, the reformulation and repetition conditions, to test how their errors and feedback to those errors impact learning. So I'll explain those conditions further in a moment, but then we see it post-test where children say goodbye to these pairs of images if their production changed based on their training experiences. So in the reformulation condition, children would see the 2 dreams appear and are told to count first, and then I respond with the correct form. Here's a clip to demonstrate what this trial looks like, and note that the black box is covering the child's face, and we instructed parents to move my face into the middle of the bottom middle of the child's screen. Hopefully the sound works.
2 snakes, 3 gooses. 2 snakes and 3 geese.
So here, since the child makes the mistake of saying gooses, my response could be seen as correcting their mistake. If they had said geese, I would just repeat their utterance, so there's no correction there. We compared this to a repetition condition in which I provide the right label first without the numbers, and then the child replies with the numbers. So they were not told to explicitly repeat, but they have the correct word modeled for them before they produce. Here's a video of this condition.
I remember some snakes and some geese. 2 snakes and 3 goose.
So here I provide the correct label before the child could make a mistake and say goose instead of geese, so my utterance doesn't give any feedback to the child's correctness. Across both conditions, the child hears the correct plural form the same number of times. Each irregular plural is used twice across the 2 separate blocks. And what's different, though, is whether the child hears the correct form before their own production or whether my utterance could be seen as feedback to their production. So given prior literature, we would expect that children in the formulation condition would show more improvement at post-test, given that they got corrections on their mistakes and can use error-based mechanisms to improve. However, our aim was to design a game less focused on word learning, so it's possible children either ignore my corrections or there's conflict with their errors they make during training, leading to worse performance in the reformulation condition. So this graph will show our mean error rates for each condition with reformulation in dark blue, repetition in gray, divided up into the pre-test, the 2 blocks of training, and the post-test. Higher bars mean more errors. And so while at pre-test, in each condition, they performed similarly, both during training and at post-test, children made more errors in the reformulation condition. In the repetition condition, children made much fewer errors, likely because they modeled after the experimenter. And not making errors seemed to help their production, as at post-test, there was significant improvement. Meanwhile, in the reformulation condition, they didn't appear to learn from my implicit corrections. And this would provide evidence for errorless learning theories and against error-based theories, as children made less errors during training, less errors at post-test. However, to test the difference between these conditions, we fitted a general logistic regression model controlling for subject and item variability, and this did not predict a significant difference by condition based on this data. This result is likely due to high variability across participants and irregular plural performance. So while there was significant learning in repetition, not in reformulation, once you account for that variability, that difference is obscured. But in the second study, we wanted to see whether learning through error correction was more helpful than avoiding errors. And here we show that even with feedback, when children make errors, they did not improve. The fact that reformulations provided no improvement was surprising. But since this correction is implicit, reformulations may not be as clear when there's no clear word learning goal, unlike previous novel word learning studies. However, this task did require children to provide information on both the number and the noun, and maybe reformulations were not helpful because the focus of the task was on identifying the correct number, not the correct name. So maybe children learn through error-based mechanisms, but only when the task is simple and focused on the item being corrected. And so we conducted a second study to address this question of whether the task was too complicated, and focusing the goal of the task on the error might help reformulations. So this game follows very similar methods, same dream machine paradigm, except instead of counting, children are only providing the labels, such as dogs and mice. And so these pairs of pictures appear outside the cloud, and then two sets of pictures will move in, and the child tells me which ones enter the cloud. Given that these are familiar nouns and the game is focused on communicating, the word learning is still not emphasized here. And so in this study, we also shifted to a within subjects design. So for each participants, half the words will receive reformulations rather than half the participants. And this allows us to better account for subject variability in irregular plural knowledge. Here's an example of the reformulation condition for this game.
What was in this dream? Spoons and mouses. Spoons and mice.
So if this was the repetition condition, I would say, I see books, spoons, and mice, but which pictures go into my dream? And then the pictures would move into the cloud and the child would label. And so this time, here we see repetition again shows improvement. However, we do see a decrease in errors in the reformulation condition. It's possible that reformulations are more helpful here because the labels are the informative part of the task, and it is a simpler game. However, it still does not seem like reformulations will be even better than repetition, as previous research indicated. Therefore, it does not seem like reformulations provide any extra corrective benefit above and beyond hearing the correct word in this type of context. So therefore, we find that both repetition and reformulation were helpful in this study. It seems that the simplicity of the task and the feedback increased the salience of implicit feedback. However, reformulations were still not more helpful than repetition, as previous research would suggest. It doesn't seem that error-based mechanisms are more helpful than learning through input or errorless production. So given these results from the corpus analysis and these two experimental studies, what can we say about the role of production and feedback on learning? Well, the results from study 2 would suggest that children do not learn through error-based mechanisms, instead learn through errorless mechanisms, as learning only occurred in the repetition condition. However, study 3 shows that more clear implicit feedback can offset this effect. Considering these results together, it seems that feedback might, at best, offset the error's negative impact on future learning, only when it is clear and more direct. But it doesn't lead to better learning than just hearing or saying the correct forms. It's important to consider, though, that reformulations could lead to more long-term learning, as this study only addresses short-term learning. Previous studies that also, feedback might be more helpful when words are newer to the child. Previous studies that demonstrated the corrective benefit were about novel words, so future research should investigate long-term impacts of error-based learning and their effect on novel word learning in more naturalistic contexts. Overall, these studies cast some doubt on the scope of error-based learning mechanisms for grammar learning. These experimental setups likely more closely represent the kinds of interactions parents and children are having together talking about familiar objects. And in these interactions, children only seem to learn from reformulations in the simplest tasks, whereas avoiding errors consistently led to improved production. So this suggests children may use error-based mechanisms as part of a suite of learning mechanisms, but perhaps not as their main tool. Parents can still use reformulations to counteract the negative impact from errors, but it seems that modeling the correct form also leads to reliable learning. I would like to thank all of you for listening, and the Cognitive Science Society for inviting me to speak here, all the RAs who helped me code all this data, both the grad students in Dan's lab and Bonnie's lab, and all the families who participated, and all you for listening. Thank you so much.
Thanks a lot. Really cool talk. Any questions?
Hi, thanks so much.
Yeah.
And I absolutely love the Dream Machine here.
Thanks.
It works spectacularly. My main question is sort of one of the differences between the exposure and the reformulation, or the repetition, sorry, and the reformulation, is the repetition, they hear it and then they get to use the correct form immediately, right? And I'm trying to think about the like snowman situation and wondering if a sort of blend of the two might be better, where you make the mistake, it's reformulated, and then you actually have an opportunity sort of immediately to use that noun again and possibly do so correctly. And if you think that might offer any advantages above and beyond your sort of repetition condition.
Yeah, I think that's a really cool idea. And I think based on the fact that, you know, when I modeled the right form and then the child would often repeat it right after me, not always, but it might work as kind of like you do error-based and then errorless learning right afterward. Exactly. And yeah, it would be interesting to see whether that would work. Yeah.
Thanks.
Are there any questions online?
Yeah. Anyone there? Right?
Not at the moment.
Hey, Claire.
Yeah, I'm curious, and I know you've actually looked a little bit at this, but I don't know exactly what ended up being sort of the result, about whether you think that like sort of more implicit feedback, like the kind featured in the last talk, would be useful in this process as well. Like if you could sort of combine more like implicit timing cues and other types of cues with these more explicit sort of like corrections perhaps that have like I guess where the content is really informative about the type of error, and what your sort of general thoughts are.
Yeah, it's interesting because it's what's funny about this error is that you still understand what the child means when they say mouses. I did look into the corpus analysis whether parents were slower to respond when a child says mouses versus mice, and we didn't find any evidence of that. It seems like it's still pretty easy for parents to process. They probably already have some kind of expectation that their child's going to make mistakes, so it's not super surprising. I don't know if there are any kinds of other signals that might indicate that there was some type of surprisal, since it seems that parents are pretty expecting of that. But it would be interesting, to see if there are other cues. Another cue could be prosody, to see whether parents respond in kind of a more like a jokey or like surprised, like, oh yeah, mouses, like if that could be any kind of signal. So that would also be something cool to look at.
Another thing would be clarification requests. I don't know if you have
Oh yeah, they're like, oh yeah, what are they called? Yeah, like asking more prompting questions and trying to get the child to try again. That would also be really interesting. Yeah.
Time for one more question.
Well, thank you, everybody.
So the last talk, last talk is going to be virtual by Alice Kane.